All right, so we know we've worked with algorithms before. Oops, I think it's kind of going all over the place. We know we worked with algorithms before in different kinds of things. We know that computer languages itself is a kind of algorithm trying to figure out how a computer language translates into what the computer is doing. So today we're going to use algorithms and we're going to figure out how to decode messages. So, what is a Caesar cipher? And a Caesar cipher is the most common kind of form of cipher or a method of encoding text, but it just replaces a letter in the alphabet with another letter that's a certain number of spaces away. As you can see right now, these two circles do not line up. That's because this one in the center is able to twist and move depending on what key you're looking for. And what key by key is whatever matches up with the letter A on the larger circle. So basically these two will be able to move, or would be able to move if this was a real cipher, if I was using real thing. If we were doing this in class, I would actually have you guys print these out, or I print these out beforehand, if we would actually make these move themselves to make messages. But since we're doing this online, I would suggest, and there's a printable section of this that I will have you, if you have a printer at home, print out. But if you prefer, you can also just make these yourself on a piece of paper and cut them out yourself. That's fine and dandy for us to do as well. So there's many different ways you can make these, but I'm sure you've seen something similar to these before, or you've made something similar, maybe even in grade school, where you put two things together to spin around each other in maybe art class or something like that. But anyway, I'm getting too focused on other things. So what you're able to do here, this specific picture right here, I would call a B key, because the letter B is right next to the letter A here. So the inner circle is the one that is your key, essentially, circle. So because the letter B is positioned with the letter A on the outer circle, this will be our B key. And so if I'm going to make a phrase, I would look at the outer circle for the plain text, but then look at the inner circle for what I want that to translate to. So for example, say I'm going to create the word apple encoded. And I'm going to look at the letter A in my plain text, my word apple, and now that is going to change to B. And then I want to use P. So P is Q. So if I'm doing this, it'd be B, Q, Q, and then L is M, so BQQMF. So BQQMF would be what apple is encoded, or using the cipher. So this is basically how you keep track of the way that the phrase or whatever is being encoded is coded. We'll kind of explain more down here. So for example, we're going to take this following message. We know that the key for this cipher is N, because again, the N this time is positioned. So someone turned this center circle so that the N was positioned with the A. And then we're going to use the word or the letters here to figure out what it corresponds to. So if I look at the letter F right here, F compares to S on the top. So now I know the first letter is S. And you can actually kind of look, I put the decoded message down here. It's called shh, it's a secret, is the message that they're trying to get you to figure out here. But you can kind of see how that works. So if I'm going to do the next letter, which is U, then U to H, and then U to H again, VG. So I'm looking for V on the center, and I'm going out to I, and vice versa. So you can either do it, if you're trying to decode, you're going to look for the inner out, and trying to encode, you're going to go from the outer to the inner. circles. We're going to keep going and exploring this in just a little bit.